Assalamualaikum warahmatullahi wabarakatuh. Good morning, good evening, and good night. Let me introduce myself. My name is Muhammad Reiyan Indra from Electrical Engineering Batch 2021. Today, I'll be explaining my experiment results of the embedded system to final project called the IoT implementation of a smart energy meter with ESP32 and Blynk 2.0 integration. Okay, so firstly, I will show you the program schematics that are mainly consist of 6 components such as the ESP32 microcontroller and the LCD I2C and the voltage sensor the MPT110B, also the current sensor, and also the results components such as the bulb connector and its power supply, as well as the supporting components such as the resistors and the capacitors. So the first thing that we had to do is to connect the voltage pin and as well as its ground pin. And after that, we had to connect the SDA and STL in this LCD into the ESP32, which is the pin of 21 and 22. The next step is to connect the ZMPT, which is the D35, and also the current sensor in the pin of D34. Both of these pins are mainly used as the deep sleep mode, which I'll be explaining later. And also we had to connect the wires inside the ZMPT110B as it has been measured by these components of the voltage sensors, and we had to connect all the bulb connector into these components, and also we had to configure these small components such as resistors and capacitors, as it has been implemented to protect the components from the overvoltage and the overcurrent.
The next step after I have been explaining about the components configuration, I'll be explaining the Arduino IDE program. This code initially begins with the inclusion of necessary libraries and the setup of Blynk credential and Wi-Fi information, such as V-calibration and curve calibration, are initialized. Then we utilize the Blynk library for energy monitoring. Blynk is initialized with the provided authentication token and Wi-Fi credentials. The Blynk timer helps to organize the periodic tasks, and several virtual pins are defined for data visualization on the Blynk app. And the energy consumption is calculated using the Blynk, and the results are displayed on both the serial monitor and the LCD. Data obtained also from energy monitoring is sent to the Blynk app using the visual writes to update the widgets in the real time. In this video, this is a demonstration of the components that I have been configured in the previous part of the contents. And in this part, we have to turn on the lights by switching on the power source. After switching on the light, the LCD will turn on and displaying the output. And after that, I had to upload the program into the microcontrollers, and the output will load. We can see in this part of the video, while the program is loading, all of the components after being executed are all restarted. After that, the output will display also in the serial monitor. This is a demonstration of Blynk 2.0 application that enables real-time updates and giving us instant access to the current state of our energy meter. We can monitor parameters such as VRMS, IRMS, power, and kWh from anywhere with an internet connection that we have been connected into our devices.
Okay, so here are the experiment results which has been shown by the graph from the Blynk 2.0 application. So the first graph is the power consumption rate, and it is seen that the power average is around 0.979. That is taken around 3 minutes. And also we could see that the VRMS graph, which has been also taken during 3 minutes, that is 142.4 V as the average shows. And also we had the kWh rate, and it is constant along the time, around 2 minutes. That is the average value is around 0.0035 kWh. Okay, thank you for listening my presentation. I'm sorry if there are any mistaken information that I have been explained. Okay, thank you. Wassalamualaikum warahmatullahi wabarakatuh.